Today we're going to talk about how to write our own subroutines or our own methods. So in Java, a method or a subroutine basically is a group of instructions that are grouped together to perform a certain task. And they are related and we give them a name. And a subroutine, sometimes you think of it as a black box because you go and you give it a command to do something and you don't really know how it's doing it. So for example, if you think about system.out.println, all we know about system.out.println is that println is a method. It's a subroutine. It has a job to do. What's the job of it? Its job is to go print what you have in parentheses and press enter, go to the next line. How does it do it? We don't know. How does math.pow calculate 10 to the power 2? We don't know how it does it, right? So in that case, we say it's a black box because we really don't see the inside of it. We don't see how it has implemented what we're asking it to do. All we know is that it takes some input and maybe it returns something back to us, or maybe we're just expecting it to do a job. So writing our own subroutines is useful because it allows you to have code reuse. You don't want to have to implement something and implement it like over and over and over again. But we don't have to know how someone implemented this method internally. So when we look at methods, there are different types of methods. There are methods that go perform a task and that's it. They don't give us anything back. We do not put an equal sign before them. So when I want the code to print something, I just say system.out.println and I give it something. Those methods that don't return anything back to us are called void methods. Compare it to math.pow. Math.pow, I give it some numbers as input, and I'm expecting that math.pow is going to give me back the answer. I'm expecting that math.pow is going to give me back a number that is a raised to the power b, 10 raised to the power 2. So this is called a value returning method. It is returning back something to us. It is not a void method. A void method has a task to do, and it will go do it, but it's not going to give you anything back. A value returning method will give you something back when it's done, and the way you save it is you have a variable equal to that. Now let's look at how to create our own methods. So there are a few words that we're going to be using, and I'm not going to really explain them now. I'll explain them later in the next chapter when we talk about creating our own classes and objects. For now, what I want you to know is that you're going to write a method. The first line of the method is called the header. And then you're going to have your open and closing curling braces, just like main has them. And all you want this method to do will go inside those two curly braces, and we call that the body. Now, when we look at a method, the first two words that we're going to write are public and static. And again, I am not going to explain those now. I'll explain them in the next chapter. But for now, all the methods that we're going to write for this chapter are going to start with public static. And then you put what this method is going to return. If it's not returning anything, like system.out.println doesn't return anything, we put the word void. If it's going to return something like math.pow, we would put the type like double or int or char. And then we give the method name. And then in parentheses, we put what this method is expecting to take as input. And inside the body, we have what the method is doing. So here I have a method print greeting. It is not going to take anything as input. It is a void method. It's not returning anything. And the purpose of this method is to ask the user for their name, read it in, and then print a message, welcome, with their name. So that's the purpose of this method. Now, if I wanted to call this method, the way we call the method is by putting the method name. We don't put public and static. We don't put the return type here. So let's actually go and start writing our own method in main. So in NetBeans here, I will start writing some methods. So you can write the methods either after main or before main. As long as they are inside your class that you have here that matches the name of your Java file, you're fine. It can be before main or after main. It cannot be inside main. So when you're creating a method, it doesn't go inside main. So here I'm going to write a method that's very similar to the one we have in the slides that says print welcome. And this is not going to interact with the user. So it's just going to say, let's say, welcome to the game. Hope you have a good time. So this is a method that is a void method. It doesn't return anything, and it's not going to take anything as input. So if I want to call it, all I do is I put the name of the method. So the name of the method is print welcome. And I look in here and it doesn't take anything in parentheses. I'm going to put empty parentheses. Okay. And so now if I run it, it will main will call print welcome, and print welcome will print those two lines for me. Welcome to the game and hope you have a good time. Okay. Now, just because I wrote a method inside a file doesn't mean it will get called. So if I didn't call print welcome in my main, print welcome is not going to get run. So here nothing gets run. So you must call the method for it to take action, to get called. So if I want to call this method twice, for example, I can do that. Okay, so now it got called twice. Okay, so again, to just reiterate, to create a method, you put public static, what the method is returning, the name of the method, and in parentheses, what this method takes as input. Right now, we're writing the simplest method. It doesn't take anything, and it's not returning anything for us. Okay. Now, how about if you wanted to write a method that actually takes arguments? Well, when you're defining that method in parentheses, you're going to have to define what kind of arguments you want it to take. That is accomplished as if you're creating, you put something in there as if you're creating a variable. So you have to say the type of the data that you're expecting it to take as input, and you have to give it a name. And then when you have this variable, you can actually refer to it in your code. So here I have print greeting. It's taking a string as input. We're going to refer to that string as greeting. And then I refer to it in my code with the word greeting. When I call this method, I say print greeting is expecting a string. So I have to make sure I give it a string inside. Okay, so let's try writing that. Let's try writing here a method public static void print welcome. And this one takes the name of the person. So in this case, this method is going to print a welcome message with the person's name. Plus name. So it's referring to this variable here. And so if I wanted to call this welcome version of, I would say, oops, I would have to give it a name. Okay, I can give it a name that is just a string literal, or if I had like a variable, let's say n equal to dog here, I could say print welcome and give it n. So as long as I'm giving it a string, it doesn't matter whether the string is a variable or it's a string literal. It's just a string. Can I give it something that's not a string? Can I give it a char, for example? No, it's not going to work. And it's going to give us incompatible types. Char cannot be converted to a string. So it's expecting a string. I must give it a string, either a variable or a string literal. Okay. Now, when we're calling these methods, like we said, we have to make sure the type of the data that we're calling it on is correct. So like I said here, I can't give it a char. I can't give it a number. It's not going to work. Okay. I have to give it a string. With numbers, if you want to write a method that kind of accepts all kinds of numbers, remember when we talked about the data types. So if I go back and kind of start reviewing data types, we have byte, which goes up to about 127, and then we had short, and then we had int, okay, and oops, we had long. So those were our data types for whole numbers, and then we had float, and we had double. So if we think back to how much RAM space each one of these is taking, you know, byte only takes 1 byte, short takes 2 bytes, int is stored in 4 bytes, and so on. The biggest one of these is double. Double can support whole numbers and decimal numbers. Double can store up to 8 bytes. And so when we talk about if I want to write a method that is going to accept any type of number, if I make it take a double, it will work. And that is why if I look at the math dot, let's say any of the methods, like for example, POW. POW here is taking 2 doubles. If I call it with, 2 and 5, or I call it with bytes or anything, it will work. Why? Because double is the biggest data type. And if I'm saying that this method can accept doubles, that means it has space in RAM saved for a double. And so I can stick anything in there. If I want to stick a 2 in there, it'll fit. I want to stick a byte in there, it'll fit. I want to stick a float, it will fit. And so when we're writing those methods, if you're writing methods that take numbers as input, if you write the method as taking as double, you will be guaranteed that this method will take anything as input that's a number. So here I have show number, it takes a double as input. So if I pass it in double x, it'll take it. I pass it in 2.0, which is double constant, it will take it. If I say x plus 3, it'll take it. If I say math.pow x comma 2, it'll take the 10, raise it to the power 2, which is 100, and then it'll pass the 100 to show number. So it will take this number in any way. It can be hard-coded, a hard-coded number. Okay, it can be a number that is a variable. It can be a result of a mathematical operation. It can be a result of a call to another method. As long as in the end, what's in parentheses can get translated to a number, this method will work. And like I said before, if you try passing in something that is incompatible, it will not work. So if I try passing in high to show number, I can't convert high to a double. If I try passing in 10 comma 4, it's not going to work because show number is expecting only one double. Can't give it 2 numbers. If you want to write methods that take 2 numbers or 3 numbers or multiple arguments, you can. So here I have a method called print division that's taking 2 doubles, A and B, and it's returning the answer when I try to divide A by B. Let's write a method like this. Let's practice doing that. Okay. So let's here come and write a method. Public static void print. Let's call it print message. And it takes a string, which is someone's name, and int, which is their age, and a float, which is their salary. Okay. And it's going to print a message using all these arguments. Ln name you are plus age and you make plus salary a year, for example. Okay. Now, if I want to call print message, I have to make sure that I say print message. This is the name of the method. And then I have to give it a string, an int, and a float. And here order matters. So if I give it a string, let's say cat, 10 years old and makes $1,000. Okay, let's put a dollar sign. And let's try testing it out. And it printed cat, you are 10, and we need a space here, and you make $1,000 a year. Okay, so what happens is cat is getting copied into the string name, the 10 is getting copied into age, and the 1,000 is getting copied into the salary. Does order matter? Yes, order matters. If I come here and I change this to 1,000 comma 10, now my message that's printed is wrong. It says you are 1,000 and you make $10 a year. It is wrong because now 1,000 got copied into age. So the order that you call the arguments in matters. It has to match what the method is expecting as input in that order. If it's expecting here 3 arguments, you need to make sure you call it with 3. If you give it 4, it's not going to work. You give it 2, it's not going to work. It has to be the exact count and the exact type. Now, when we call a method, there's something called pass by value, and I'm going to show you an example, and then I'll draw out to you what's happening underneath. So let's here have a method called public static void change to 100. Okay, so this method takes a float grade, and what it does, I'm going to just print out, what I got first. So I'm going to say I got grade plus the grade. And then what it's going to do, it's going to say grade equal to 100. And it's going to print out a message saying that it changed it. Changed grade to. You want to make sure that it got changed to 100. Now here in main, what I'm going to do, and I'm just going to comment these lines out because we're not going to need them right now. Here, let's say I have float grade equal to 50, and I'm going to say system.out.println in main grade is plus grade, and then I'm going to call change to 100 on this grade that I have, and then I'm going to put the message again, main grade is now, and I'm going to try to print it. And the question that we want to ask ourselves is, here, when I print the grade, I'm going to see that it's 50. Then change to 100 is going to get called. That 50 gets copied into here. I'm going to see 50. Here, I'm going to see the grade is changed to 100. So here I should see that it's 100. Now the question, when the code comes back, what am I going to see as the grade here? Am I going to see that it's 100 because this method got called and it changed it? Or am I going to see the old value that is here in main? So that is what we're trying to look at. And when we run it, we find that in main, it used to be 50, changed to 100, got 50, it changed it to 100, but when the code went back to main, it was still 50. And what we want to see is what is happening in RAM. So here, what I'm going to do is I'm going to kind of try to draw out what's happening. So in main, we have a variable called grade, and that grade has 50 in it. Okay, and then change to 100, just going to call it change here, got called, and change to 100 also has a variable called grade, because that is the variable that got called here. Okay, so it's creating a variable called called grade, which is a float. And so what happens is when main calls change to 100 with the grade, which is 50, the value of 50 gets copied over. So it's going to get copied over. And so now this variable in RAM has 50 also. So now I have two places in RAM that have 50. One variable called grade, which is under main, and one that's called grade under change. And we're going to talk about having the same variable name in a little bit. But here, the 50 is going to get copied over. So when change to 100 comes and says grade is 100, what I'm actually changing is this variable in RAM that's part of change to 100. It's not changing the one in main. So I'm only changing the one here. And so because the value got copied over, any change that change to grade does or change to 100 does will not be seen in main. So this concept is called pass by value. Okay, so pass by value means that the value that is in a variable is going to get copied over into the method, and the original argument variable will remain unchanged. Okay, and so here this code is very similar to the one we did. Here I have a method called give extra credit. It has a value and an amount, and in main we're calling it with the grade, which is 90 and 5. The 90 is going to get copied into value. The 5 is going to get copied into amount. When give extra credit changes the value, it's only changing the variable here. So this value is no longer 90, it's 95. 90 plus the amount, 5. So value here is 95, but grade in main remains unchanged. Okay, so here the grade was 90. Here we have value, got copied the grade, which is a 90, and it has amount 5. When I make a change, I'm changing the value to 95 inside my method, and so main doesn't see the change. Okay, so the grade remains unchanged in main. This is because we are passing by value. Later in the next chapter and more in Java 2, we're going to talk about a way of calling methods where we actually give it something, we give it an object, and the object indeed gets changed. It actually gets changed. But with primitive data types, it does not get changed. Now, the next thing I want to talk about is local variables. So notice here, when I created a variable called grade, okay, I was able to here also call grade, create another variable called grade. Another thing is if I have here a variable, let's create a variable here, let's say int x equal to 10. Okay. If I were to come here and try to print out x, change to 100 is not going to find x. It's going to say cannot find symbol. So whenever I'm trying to use a variable that doesn't exist, you always get this error message, cannot find symbol. And so why is it that the x created here at line 28 is not seen at line 38? And that's because variable x lives inside of main. This variable got created in RAM at line 28, but only under main. So it is living in the space of main. Other methods do not see that variable. Other methods can actually create other variables that have the same name. And these variables can even have different types. They're totally different spaces. So imagine you could kind of think of RAM as broken up into different spaces. This is the space for main. This is the space for change to 100. They both can have the same variable names. It's okay. They don't see each other's variables. So each method has its own space in RAM. Oops. Each method has its own space in RAM. So anytime you create a method, you're creating, so if I have main here, main has this space in RAM. And change has another space in RAM. And like another print method, for example, like print welcome has its own space in RAM. And each one can create its own variables, x, y, a. Okay, they can have the same names if they wanted to. It doesn't matter. Because each person, each method owns its own RAM space. Each one of them can put different values. Okay, so they can have different values. They can have different names. So these are called local variables. They are local to the method that they are part of. Okay, so here we see in main, we have a variable called student count. Okay, that's 2000. We have Java class has a student count, which is 24. We have a Python class that has a student count of 18. So here, when I call Java class, it's going to go into Java class and print Java class has 24 students because that is the variable that is in its space. When I call Python class, I'm going to see Python class has 18 students. In main, when I try to print it, I'm going to see MCC has 2000 students. So each one of these methods has its own local variables. They are local to the method. Other methods do not see the variables of the other method.